Number 8, we're once again going to end up using some inverse ratio, trig ratios to solve for this. We're trying to look for what angle A is. So angle A, I'm going to mark this down here. That's my reference angle. That's what I'm trying to solve for. And so I need to determine if I'm going to use sine or cosine or tangent based on the side lengths that are given to me. And so if I look at angle A as my reference, that side is going to be the adjacent side, the one that's right next to it. Across from it would be the opposite side. I don't have that. But this side length of 12 is going to be the hypotenuse because that's across from the right angle. And so I've got the adjacent and the hypotenuse sides. So when I look at SO, CA, TOA, I find adjacent and hypotenuse right here. That's part of cosine. So I know I'm going to make use of cosine, and the cosine of the angle that we're looking for is cosine of angle A. The cosine of that angle is a ratio of adjacent side and hypotenuse side. The adjacent side was 7 and the hypotenuse side was 12. Okay, so what this says is there is a cosine ratio of a certain angle that is 7 to 12. What is that certain angle? That's what we're looking for. I want to get A by itself. I don't want to have the cosine of A. I want to have just A. So to undo this, to get A by itself, I'm going to take the arc cosine. The arc cosine of A is going to get me A all by itself. And if I do that to one side, I've got to do that to the other side too. The arc cosine of 7/12 is going to give me an angle measurement. When I use my calculator, and I got to check that I'm in degree mode, I plugged in the inverse cosine of 7/12. I got 54.3 degrees, or pretty close to that. And I know that this is correct because 54.3 degrees is the only angle measurement that has a cosine ratio, an adjacent over hypotenuse ratio, of 7 to 12.